Hello Geometry, welcome to 1.4, Measures and Classifying Angles. So our learning targets, I can identify and classify angles. I can use tools to copy and bisect, meaning cut in half the angles. And I know an angle bisector divides an angle into two congruent angles, which gives them two congruent or equal measures, not congruent. Congruent angles, equal measures. All right, first of all, you're going to notice that we're going to solve two equations, combined like terms. One of them is set to 90, one is set to 180, because we'll be doing that in the future. So the first thing I want to do is combine like terms. 5x and 2x is equal to 7x. 6 and negative 14 is negative 8 equals 90. I want to add 8 to both sides. 7x is equal to 98. Divide by 7. X is equal to 14. Naturally, I do not have enough space, but we can work this out. All right, part B. 4x and 1x is 5x. Negative 30 plus 25 is a negative 5 is equal to 180. Let's add 5 to both sides. 5x is equal to 185. Then divide both sides by 5. X is equal to, I believe, 37. Please double check that. Let me know. Now this one's interesting. Notice we have x over 3. That's the same as 1/3 x. I want to subtract that on both sides. These will cancel. I have 2 equals. Now, when there's no number in front of x, that's the same as 3 over 3. Because 3 divided by 3, can you see that, is a 1x. Minus 1/3 x is 2/3 x. So what I have so far is 2 is equal to 2/3 x minus 5. Now I want to add 5 to both sides. 7 is equal to 2/3 x. Now, how do I get x by itself? Multiply both sides by the reciprocal. I like to do that in another color. I'm going to use this. I keep forgetting I have these multiple color pens. Here, the 2's cancel, 3's cancel, and I will have 3 times 7 is 21 over 2. That's what x is equal to. All right, not too bad. All right, so here we go. Now let's look at some notes. Have your highlighter ready, or maybe another colored pen. I do like to have this pink pen handy just in case. All right, here we go. Angle. We now have an angle. Consists of 2 different rays. So this is one ray. And this is another ray. And notice they have the same vertex. Okay? So the rays are the sides of the angle. The endpoint is the vertex of the angle. How do you name these angles? Well, let's say this is A, this is B, and this is C. So by doing that, we can call this angle B. We can also call it angle ABC, or angle CBA. Notice the B is in the middle for both of these. So if you're going to be labeling or naming an angle, always make that vertex in the middle. Okay, now look at this one, example 1. Can you see that? Wonder why this is like this. I got a weird glare in here. Okay, name the 3 angles in the diagram shown. Okay, so we can do the whole angle, the whole big thing. So we're going to call it angle ABC, or angle CBA. Now let's do the top one. That would be this one right here. Angle ABD, or angle DBA. And then the bottom one, that's this one, angle DBC, or angle CBD. Notice that vertex was in the middle for all of those. All right, the next thing we need to do, protractor postulate. So here's our protractor. I like the blue ones. Glad that you could see actually this in the screen. Considered OB. OB is this whole line. Remember, lines go on forever. And point A is on one side of it, so it could be anywhere on here, on this side. Or I guess it could be down here. We can always turn that protractor upside down. The raised form OA can be matched 1 to 1 with real numbers 0 to 180. In fact, it could actually be like even the integers in between. You can have like 60.5 and anything else in between. But it's a lot easier to just put them on whole numbers. Now notice when you have a protractor, there's a dot. That's usually where your axis is going to be, or the end point is going to be. Line up with this line. You're going to start here, 0, 10, 20, all the way around to 180 degrees. 180 degrees will equal your straight line. Okay, so let's move on from there. Next page. Okay, now classifying angles. So angles can be classified depending on how many degrees they are. So an acute angle. So any angle, if we call all of these angle A, the measure of angle A is less than 90 degrees. A right angle, measure of angle A is equal to 90 degrees. Obtuse angle, measure of angle A is between 90 and 180. So let me put this down here so there's more space. Measure of angle A is between 90 degrees and 180 degrees. A straight angle, measure of angle A equals 180 degrees. And of course, this is greater than 180, and a complete circle is 360. Now, let's find some of these values. So go ahead and work these out. COA, starting from 0, it's going up to, looks like 50 degrees. Then it says classify. Well, that's a small angle, so acute. All right, FOC. There's FOC. Now this is going from 140, and C is at 50. So 140 minus 50, that's equal to 90 degrees. This is a right angle. GOA. Let's put G right over here. Wonder how I lost that somehow. GOA, that's 180 degrees. It's a straight angle. And AOD. AOD, that's 90 degrees. It's a right angle. Well, I'm not sure what's compelling me to do this, but let's put a part E here. Let's find angle FOA. And there is a reason why I always put a little arc in there, because I don't want this to look like the lesson symbol. So FOA. FOA, that is 140 degrees. That's an obtuse angle. I guess we didn't really need that, but it's okay. So practice playing measuring angles. How about this one? Angle addition postulate. So just like the segment addition postulate, we have an angle. If P is in the interior, okay, so here's our angle right here. P is inside of it, so of angle RST. Then the measure of RST is equal to the sum of these two angles. So the measure of the whole angle is equal to this, these two added. So if we can call this angle 1, we'll call this angle 2. Basically what that means is angle 1 plus angle 2 is equal to angle RST. All right, so let's apply it. Number 3. Can you see that? Okay, so adding number 3. Measure of ABC, that whole thing is 124. So let's find these two. That means these two will have to add up to equal 124. So 3x plus 1 plus 4x minus 3 is equal to 124. So this is kind of like our warm-ups. Combine like terms. 7x minus 2 is equal to 124. Add 2 to both sides. 7x is equal to 126, and then divide by 7. X is equal to 18 degrees. Now, you've got to keep in mind, a lot of people like to stop right there, but look at the directions. Now find the measure of each angle. So, if you substitute 18 here for ABD, you have 3 times 18 plus 1. That's going to equal 55 degrees. And substitute in here, we have 4 times 18 minus 3. That's equal to 69 degrees. And again, these two angles should add up to equal 124. Double check, okay? Find all angles. Look at example 4. You're going to see lots of problems like this. First of all, whenever you see a little box, that's 90 degrees. Okay? So right here, we have a straight angle. If 90 is right here, that means these two together are 90. And notice, see these little arcs here? The arcs with the line? That means these are congruent. So if those are congruent angles, that means the measures are the same. What two angle measures will add up to equal 90? 45. Now, we have a straight angle right here. 180 plus 40 plus what? Wait, 45 plus what equals 180, because these two make a straight line. So this will have to be 135 degrees. And then look at this. All three of these angles have to add up to equal 180. So this is also going to be 45. So pretty nifty. But one thing I really want to point out would be these two angles right here. Again, these have that slash mark. They're the same. These also has a slash mark, so they're going to be the same. But notice the two lines will make these two angles. It has a special name called vertical angles. We're going to learn that a little bit later, but these are also congruent. All right, two angles are congruent if they have the same measure. So two congruent angles. Notice the notation. The measures are equal, but the angles are congruent. And again, I like to put little arcs in those angles, just so it doesn't look like a less than symbol. I think the next thing is construction. You can try to do the construction on your own. Again, we might say this for the class, depending on how much time this video is taking. I forgot to look at my watch when I started, so I'm not sure where it's going. But first thing you want to do is make a segment. You want to copy this angle. This is the angle we want to copy, so make a segment, draw an arc, measure that distance, and go for it. But we're going to do this in class, if not another video. Angle bisector. Angle bisector cuts it in half. Okay, so see these two angles? They are the same measure. If they are the same measure, the angles are congruent. That means AC, this ray, is an angle bisector. It cuts that whole angle ABD right in half. So example 5. It tells us BD is an angle bisector, so find x and then the two angles. Well, once you find one, you'll know the other. They'll be the same. So these two have to equal each other. So 2x plus 50 is equal to 5x plus 5. So I want to get x's on one side, numbers on the other. So I'm going to subtract 2x. 50 is equal to 3x plus 5. Subtract 5. 3x is equal to 45, then divide by 3. X is equal to 15 degrees. Again, many students will stop right there, but now you have to substitute in. So, let's do it to this one. 2 times 15 plus 50. Well, 2 times 15 is 30. 30 plus 50 is equal to 80. If this one's 80, this has to be equal to 80 also. So please keep that in mind. And then the whole angle is going to equal 160, because add up each part. And again, here's our last construction. We'll do that in class, or it'll be in the Part B video. Everyone, have a nice day.